Hey everybody, today we will do another video and we will continue on the vector product. So basically we will do a couple different things here, right? So it's going to be one example, not gonna probably this video not gonna be too long, but it's going to be a little bit involved, right? So so what we're doing is projection using the dot product, but we will not do a lot of projection now, right? So basically we're just getting into projection. So projection using the dot product, that's what it is. Projection using the dot product. So it says if U and V are non-zero vectors, right? If U and V are non-zero vectors, then the projection of U onto V is given by the projection of U onto B is given by the kind of like that U equal U dot V U dot V U dot V U dot V over the magnitude of U of V squared, and I take this and multiply it by V, right? Okay, so with that being said, he says that the projection of U onto B as a scalar unit vector in the direction of the B. So what they're saying is that this right here is also equivalent to, so U dot V over V over the magnitude of B squared, right? This is B, the magnitude of B squared times B times the vector B is equivalent to K V over this, because I can actually break this into two, right? I can break this on one of this, I can put it under this, which is nothing but V over one of the magnitudes, right? So I took only one magnitude and put it here. That's what it is. So because technically I can write this, this vector v, I can write it separate, right? I can separate this. One v stays under this and another v stays under this. In other words, I can write this as this. See? Right? I can do that. So, right? Now, this k represent where k represent one of those, which is like this. So it's going to k represent u that v over the magnitude of v, right? Just like that, right? So k represent this. So k represent this piece. So that's why I replace that by that. See? Okay. I replace k by this when I factor out v, one of the v, the magnitude of v, that is v in a square. Okay. Okay, so then the scalar k is a component of u in the directions v, right? This is the scalar. The scalar k is a component of u in the direction of v. Right? So, okay, so now let's do an example, right? Now that we know a little bit of what this is, let's do an example. So, let's do an example real quick. Okay, so they saying that the example says decomposing a vector into vector components, right? So decomposing a vector into vector component. Right? So it says, now it says find the projection of u into v in the vector of u. Okay, so it says find the projection of u and v in the vector component, right? In the vector component, right? Of u orthogonal to v for the vector, right? Let me write this down. Let me write this problem down. So this is what we're doing, right? This is what we're doing, right? Now we need to write the problem down, right? So example, this is example that we're doing. So it says find the projection of u into v of u onto v in the vector component and the vector and the vector component of u orthogonal of u orthogonal to v for vector u equal to 3i minus 5j plus 2k and in vector v and v equal to 7i plus j minus 2k. Right? I don't know if you noticed something here, right? I don't know if you noticed something, but see the k on both sides is negative. It's negative and positive, which means that the k is going to cancel each other out, right? If I add those two, the k is going to cancel each other out, which means that it's going to be just two parallel planes. It's going to be just x and y instead of z, right? Okay, so let's get started with this. This is what we're doing, right? So it's part of the projection, but again, so let's get this going. Okay, so first of all, we need to do the book. Name this as W. So W1 is equal to U dot V over the magnitude of U squared multiplied by the vector V. Now your W1, so W1 will be the projection onto U, onto B, right? Projection of U onto vector B, right? Then, then we will do something else to find the orthogonal to B, to the orthogonal to vector to B. I will show you how to do that. Okay, so let's get this started. So let's get started this. Okay, so let's do this, right? So we want to find W first, and W1, right, is equal to W1 is equal to we need to do the dot product of this, right? So how we do the dot product again, right? So we need to go back to the basics where this we have been building up in this, and we do U and V, right? So we have a 3i minus, and remember when I write this, I have to kind of put it, between like this. Just all I have to do is be careful with the signs. If it's positive, I don't put any signs on it. If it's negative, I include the signs, but I am extracting these values. I am extracting, okay, so let me just, okay, I am extracting the values of the coefficient. That's what I'm trying to say, right? That these values of you will say that, the magnitude of vector of the, according to the direction, right? So because this is actually x, y, z, right? So I will extract those values and put it inside here like this. So we'll have that 5, negative 5, comma, 2. Dotted with, and remember, this is ijk. So I have to be careful, right? When, just counting that I got an ijk and this oxyz, right? So I am dotting this with what? With v, right? With v, which v is 7i 1j negative 2k. So 7 comma 1 comma negative 2 close parenthesis. Okay, so I am dotting these values. This time is this is what? This time is this is 21, right? This times this is 21. 7 times 3 is 21, right? Now, here, plus what? I'm adding this, I am doing this 5 times the corresponding value of j, right? So I did the i's already, now I gotta go with the j's. J times the value of j, which is what? Negative 5 times 1 is nothing but negative 5. Plus 2 times a negative 3 is nothing but plus a minus 4. Add them together, right? When I do this, this is 9. 21 from 9 is equal to 12, right? Now I got this value already, right? I got that. Now let's do the bottom. So in the bottom, I will take the value of v, which is this, right? And I will take the magnitude of v, but remember this is a square. Be careful, that's a square. So the magnitude of v is what? It's going to be equal to the square root of the square root of 7 right 7 plus 1, 7 squared plus 1 squared plus 7 squared plus 1 squared plus 2 squared, right? See how I gotta be careful here because I'm making sure that if it's negative, I put inside the parentheses, right? That is telling me that I have to square the negative, right? So now I do that, right? And that is technically, right? So now I gotta do this, right? So the magnitude of that is what? Is going to be equal to 49 plus 1 plus 4, right? Because this time, this by itself is negative. It's positive, right? Negative times a negative is a positive. So I get what? I get the magnitude of that is nothing but this is 49. So 49 plus 1 is 50. It's the square root of 54, right? Now, remember, this is being a square, right? Because that's what the formula says. I need to square that, right? So technically, if I square that, so let me just put it like this, right? Just make it sure, right? Okay, so if I square this side, right, and I square that side, I will get rid of that square root, right? So if I do this square, I get 1 here, right? Then if I do this on the other side, right? Let me just do it step by step so you can see it. So if I do this, right? And then like this, and I square, right, on both sides, right? And I square this 54, right? When I square that, I get rid of this square root, which means that it's equal to 54, right? Okay, so now I found out that this one is equal to 54, right? Okay, I put that there, right? So what do I get? I get the following. I get 12 over 54, right? Which I found it, right? Times the vector v. What is vector v? Well, vector v is this, right? So times vector v, which in this case, let me just write this, because I know what that is already, so. Okay, so times vector v, which is nothing but 7i plus j minus 2k, right? Now, notice that it's still, what is the formula telling me? The formula is telling me that after I do this operation, I have to simplify, right? So I need to simplify that, which is W1, right? If I take these numbers and divide it by, if I divide this by top and bottom by 2, what I get in the top, I get 6. Actually, divided by 6. Divided by 6, I get 2, right? If I divide 54 divided by 6, I get 9, right? Now, taking this, 7i plus j minus 2k. If I distribute this piece on the top, right? If I distribute that, and I distribute that, I get 14i over 9 plus 2j over 9 plus or minus, we'll say minus 4k over 9, right? Okay, so that is W. That is the projection of V of U onto B, right? That's the projection. Now, it says the vector component of U orthogonal to B is the vector, right? So basically, now to find the vector component, the orthogonal of this, I need to subtract the projection from the vector, right? From V. No, from U. I need to subtract the projection, right? From U. So that was the projection of U onto V, but then I have to subtract the projection of U from the original U, right? So because this is the projection, right? So this is the projection. So projection of U onto V. Projection of U onto V is equal to what? Is equal to 14 over 9, 14i over 9 plus 2j over 9 minus 4k over 9. So this is the projection of U onto B, right? Now to find the orthogonal of those, I have to subtract the projection of U onto B from U, right? So I need to subtract the projection of U onto B from U, and that is going to be W is equal to U minus W minus W1, right? But what was W1? What W1 is the projection, right? The projection of U onto B. Okay, so let's get this going. Okay, so now what I can do right here, the following. So I write the projection, I write U, the vector U, right? Which is this, right? Minus that, right? So I'm going to get 3 So I'm going to get 3i minus 5j plus 2k, right? You put in parentheses like this, minus 14i over 9 plus, let me just write it like this so it doesn't get confusing, right? So I, right? And then plus 2 over 9j minus 4 over 9k. Okay, let's go back again and again and again. This is mathematics. So whatever we learned in basic math, 5th grade, right? Fractions, it will pop up over here. So yeah. So that's why we need to build up in mathematics. Because that's how mathematics works, right? So now we have something right here that's called a common denominator. See how I got all the bunch of 9s over here, right? Nice. I already have the common denominator here, but I don't have it here, right? I don't have the common denominator in this thing. So this is minus 5j. Okay, so now I need to find the common denominator of this part, right? Which is already 9. But what I can do is multiply by 9, top and bottom, right? Because that's what the common denominator is, right? So this times this is what is equal to, this times this is equal to 27i over 9, right? And then this times this is negative 45j, right? And then this times this is nothing but what? This is over 9. This is going to be 18 k over 9, right? Now I have the common denominator in this part, and I'm subtracting that part, right? Let's see. So this is W2, right? W2. Let me just make it clear that you can actually see that. So W2, right? So now I'm multiplying to find the common denominator, top and bottom by 9, right? Now I'm subtracting this part, right? So when I subtract this part, remember, again, the rules of mathematics, 14 over 9j. Now I can do it like this. I plus 2j over 9 minus 4k over 9. Now, again, when I do that, this becomes a plus, right? And then this becomes a minus. This, because this was a plus initially, it was a minus initially, right? It was like that. That becomes a minus. That becomes a minus, right? When I change to a plus, this becomes a minus, right? And this becomes a plus. See? Why? Because this is negative, this is negative. So if I distribute that sign across, I get a positive, right? Negative times a negative is equal positive, right? So now I got this. Okay, so now what is my next step? My next step is simply just add them up, right? So here I get what? I get 3i, right? Subtracting one of those, I get 13. So W2 is equal to what? Is equal to 13i over 9. Alright? And here, so here I am subtracting this, but is this a negative? Both. See that? Negative 45j and negative 2j, that is equal to negative 47j, right? Again, the rules of basic mathematics are popping up. So, okay, so negative 47j. Okay. Negative 47j over 9, right? Okay, so positive 18k plus a positive 4k is equal positive 22k over 9. Right? And that will be the orthogonal, the vector component of u orthogonal to v. Right? This will be so okay, the vector component of u orthogonal to of u, right? Of u orthogonal, of u orthogonal to v, right? So the vector u orthogonal to v is what I got right there, which is w2 equal 13i over 9 plus minus 47j over 9 plus 22k over 9, right? Okay, so of course you can factor 9 out and put 1 9 and then put this inside the parenthesis, but it doesn't make any difference. So that is the vector component of u orthogonal to vector v, right? To vector v orthogonal to, just let me do it here, orthogonal to vector v, right? Orthogonal to vector v is this one. All right. So that's it for today. I hope you enjoyed this video. If you do, please give me a like. If you have not subscribed to my channel yet, just go ahead and do it because that will kind of motivate us to do more videos, and also it will put these videos on the top so more people can actually see and learn about this good stuff in mathematics. Some beautiful stuff here. All right. Thank you for watching.